This is the agenda of this topic. Includes Intel process trace overview, some hardware enhancement, what we do to enabling this feature for Xen Hypervisor, and at last we will make a brief summary about this feature. This page is Intel process trace overview. Intel process trace is a hardware feature that records the software execution information. This uses dedicated hardware to capture the information about the software execution to a physical memory buffer. And the next step, we can use a decoder to determine the exact flow of the software execution. This decoder may be per, VQ, or GPA. And GPA is about this feature, and we can use GPA to make backstep debugging. That is, the software can process the captured trace state and reconstruct the exact program execution flow. Because this is a hardware feature, so this have a log overhead to system execution. This page I list part of the Intel process trace data package, not all the package, because there is so package type is so much. First is about the control flow package. That is taken, not taken, target target instructor pointer, mode target, and so on. This package can be produced by branch instruction, interrupt, exception, mode chunk, and VM exit and VM entry. When we change the CR3 or task switch, the PIP package will be produced. There also have some time package. These packages are practical and based on the core crystal clock and the software configuration. The next package is the VMCX package. This is also configurable, and this package is used for the virtualization. We can use in the system mode and trace the host and guess the trace. And this package, we can use this package to know which part is belong to guest and which part is belong to native. The last one is the overflow package. This package is will at the end of the region. If we find this package in the buffer, it means that there maybe have some packages are lost because we didn't get the trace timely. This page I introduced some specific use case of Intel process trace. First is a trigger save of Intel process trace log for post modern analysis. This save on crash, call dump, and software event. The next one is we can use this feature to debug short-lived, non-steady-state performance issue. This can catch some hard to catch with simply, but the process trace can capture everything with Paris time info because we have some timing package. Intel process trace also provides a path history even when the stack is corrupt. This replaces the call stack info with a full time control flow trace. We also can use this feature to diagnose code coverage because this can record the footprint on program execution. All this use case is based on the Intel process trace can record everything on program execution. This section I will introduce some hardware enhancement for virtualization. First, we add a new byte in a register. This is the capability of if we can enable Intel PT in VMX operation. The next one, we add a new get state field for VMCS. This can speed up and simplify the process of disabling trace on VM exit and restore the get the status on VM entry. The next is the most important hardware enhancement. That will use the EPT to redirect the PT output address. Because we need on native, we need to set we need to allow the buffer and set a physical address to the hardware to save the process trace. And in virtualization, this is a GPA, and we need to use the EPT to translate this address. That is CPU will treat PT output address as GPA and translate then use EPT. And we also add new VM exit qualification for Intel output. This is add some new bit in the VMCS. That is to control if we need to produce the VMCS package. This is can use for in virtualization. If we need to mark non-root mode in package, for example, there are bits in PIP package. If the PIP package is different on native and guest, and we can use this flag in this packet to know if this is produced on guest or host. And we also can control the register. We also can control the register auto save and restore when exit and entry. The last one is the output buffer address be treated as a GPA and translated by EPT. At least two mode in Xen Hypervisor. First is the guest mode. In this mode, the guest can use PT like native. In this mode, we will expose the Intel PT feature to guest, and the guest and in the guest only trace guest and output to guest buffer. In this mode, DOM0 can't detect Intel PT. The next mode is system mode. In this mode, we need to set PT buffer for Xen Hypervisor, and this buffer will include the hypervisor's trace and guest trace. This we can use for debug Xen Hypervisor and guest. A little different with guest only mode. That is, we won't expose this feature to guest. Because the enterprise trace is depend on EPT, but the DOM0 is a PV guest and don't support the EPT. So I need also to set this buffer for hypervisor. So we need to do some change in PT driver and add some PV interface to set this buffer for the hypervisor. This section is about what we do to enable enterprise trace for guest-only mode. First, we need to emulate the CPID information. Lib7 includes the enterprise trace feature, and Lib14 includes all the sub-feature of enterprise trace. Because on the different platform and the different hardware, the sub-feature may have very different. The next one is some VM size configuration. First, we need to let the address of the PT output can be translated by EPT. Another is we need to set to auto save and restore the PT control register, the value from to or from get state area. This happened during the VM entry and VM exit. And we don't need to include the VMCS package and the network bit in trace package because we hope the guest can use the PT like native, so we don't need the guest know he work in the network mode. Next one is the MSR read-write emulation. We need to inject GPU when guests trying to read-write unspotted bits or MSRs. There are a lot of security check because some bit is depend on the spot of the sub-feature and some MSR registers is depend on the sub-feature. Next is the context switch. Is just about the VM entry and VM exit context switch. Before VM entry, we need to internalize the get state field of Intel PT control register. And the value of this get state will be auto load to the hardware before VM entry. And the other registers, we need to restore this manual. About the VM exit, we need to manual save the get state field. And the PT control register is the exception because this register can be auto saved in get state. It can be auto saved in get state before VM exit. Next one is we need to inject the PMI to the gas because the processor will signal a PMI when the corresponding trace output region is filled. So we need to emulate and inject PMI to gas. The next one is we need to disable Intel PT in nested virtual machine because there have a risk when L1 hypervisor work in sys mode when EPT on EPT. That case is the L1 hypervisor work in gas mode. That's the L0 hypervisor work in gas mode. That's the L1 gas can detect this feature, and the L1 gas can use the system mode to create a L2 gas. But if the L1 gas work in system mode, L1 gas will set a GPA, as a PT output buffer. But when the L2 gas is running, if the L2 gas is running, the EPT mapping is from the nested GPA to HPA. These are different EPT mapping. So in the L2 gas, there is no EPT mapping for the EPT for EPT address base for PT address. So we need to disable Intel PT in nested. Next one is because we add some new VM exit qualification for Intel PT output. Here is some specific use case about how to handle this event. First is there don't have EP mapping for PT buffer address. In this case, we will crash the guest when the POD is not used. The next one is we set a MMO address as a PT output address. Actually, in native we can set the output address as MMO because we have a type of PCI card that streams the process trace to hardware. But in order to make the guess is more safety, so we forbidden set PT output address as a MMO address. So we will also crash the guess in this case. Other cases about for example, the PT output address is read protect. This may happen during limitation and EPT misconfiguration and the PML log 4 web message. This can handle the by the original flow. The last one is illegal operate. That we set a peak MIO address as the PT output buffer address. This is also illegal operate, so we still need to crash the guess as well. Okay, the last is brief summary about status of this feature. The benefit is it can by this hardware enhancement, it can simplify the process of Intel PT virtualization. Especially we can use the EPT to translate the PT out buffer address. Another thing is we can use the Intel PT feature to trace guest and hypervisor's behavior to do some debugging and performance tuning. And the current status, I have sent 2 versions to community, and this include guest mode. And the system mode and the PT output unit for introspection scenarios is still under consideration. Okay. Okay, that's all. Have any questions? Okay. Yeah. X-save. Yeah. Actually, this have X-save and X-store, but currently this part is not work well in Xen, and even we use the X-save and X-restore. We also need to implement this part that is context switch by manual because once the S-store and S-save and S-store is not supported, we also need to use the context switch by manual. Yeah. Have any questions? Yeah. 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 We can catch this and correct that faster. Yeah. Yeah. Okay. Okay, that's all. Thank you.